Tables to graphs. You have learned that equations and tables are two ways to represent real-life scenarios. Equations and tables can also be graphed to represent a real-life scenario. Here's an example. A cafeteria has an automatic waffle-making machine. The table shows the relationship between the time in hours X and the number of waffles the machine can make Y. So in this table, for example, the first row, we have an input of 1 and an output of 50. So that means in 1 hour, the waffle machine can make 50 waffles. In 2 hours, it can make 100. In 3 hours, it can make 150 waffles. In 4 hours, 200. And in 5 hours, it can make 250 waffles. The equation for this scenario is y equals 50x. Each hour, 50 waffles are made. The value of y depends on the value of x, so therefore y is our dependent and x is our independent variable. So if this scenario can be represented with a graph, first we need to put those variables on the graph. When graphing, the independent variable is always across the x-axis, and then the dependent variable is always up the y-axis. So once you have represented the equation in a function table, you can utilize the independent and dependent variable values as coordinates. So we had our table with x and y, and now we can have our third column putting them together as coordinates x comma y, and we can then plot the coordinates from that table onto the graph to represent the scenario. When you're graphing, and you're going from a table with coordinates to the graphing and the coordinate plane, I think it's helpful if you label your x and your y axes just to remember that you're talking about your independent and dependent variables, which one is which. And make sure when you're graphing, you always move along the x-axis first for that first coordinate and then up the y-axis for the second coordinate. So for example, if I'm going to graph the ordered pair or the coordinate 150, I'm going to go 1 over on the x-axis here and then up 50 on the y-axis to meet at this point. So this point is the ordered pair 150. I'll do another example. Let's say it's 4, 200. So I would move over 1, 2, 3, 4 on the x-axis and then up 200 on the y-axis. This is the ordered pair 4, 200. So you would continue that for all 5 ordered pairs. Then you would have this graph. So this graph is representing the table and also the equation y equals 50x for those specific x values in the table. It's representing the scenario about the waffle making machine and the amount of hours and how many waffles it can make. You can look at it graphically. You can see the relationship with more of a visual than the table or an equation. Let's try one more example. We have a bookstore is running a special and is charging $5 for any children's book. So let's look at this scenario in 3 different ways. First, let's write an equation to represent the scenario. Then we can complete a table to represent the scenario using the equation, and then graph the function using that table. So if we have an equation to represent the scenario, well, what is the scenario? Let's remind ourselves. We have, again, a bookstore is running a special and is charging $5 for any children's books. So if we use X as the number of children's book and Y as the total cost, we would have that the total cost Y would equal $5 for the number of books, or for one book. So the amount of books you buy, if you multiply by 5, that will give you your total price. So to fill in the table, we have to keep having inputs of the number of children's books we're going to buy. So for 1, the first row, you would multiply by 5. So that would give you a total cost of 5. And then that gives you the coordinate of x comma y, so 1 comma 5. If we were then to graph that, I would go over to my x-axis 1 and then up 5 on my y-axis to get my first coordinate point on the coordinate plane. And I'm going to continue that until I complete the whole table and have a good amount of points to represent the situation. So here you can see we've filled in the table for up to 5 books, finding the total cost for each, getting those 5 coordinates, and then plotting them on the graph, all again representing that equation y equals 5x. So you can see one way of looking at the situation is an equation, the second is the table, and now we can translate that using the table to translate to different coordinates and plotting them on the graph. So we can see a third way is using a graph to represent an equation.